out of time. Would you mind to explain very briefly what are the AI type graphs? I think you told me, and how it could be or it was used to de-anonymize COVID information, and then we can do the adversarial image demo.
So I said before that we had like three main fronts on AI, sorry, NLP. The thing we discussed at the beginning, ChatGPT, all of that. We have also image classification, image generation, all of that. And the third one comes to graphs, and graph is a generic data structure in the end. So you can represent anything as a graph. Basically, you can represent text and images as a graph even. So you can, there's a lot of math behind. I'm not going to go through that. I don't think it's worth it, but you can prove that pretty much all the models in place, you can replace them for a graph neural network, which is this type of approach. And this is something that is more of in its infancy when compared to the other two, but it's picking a lot of traction, for example, in biology. And yeah, in the end, anything that can be represented as a graph is susceptible of being, you can use a graph neural network to work with it. And so the example you were describing, actually, that was pretty cool, because this British researchers, they proved that you could completely de-anonymize like interactions in users from the COVID app. So we had this COVID app with very strong crypto in place to stop people from obviously identifying who was who in an interaction. But these people show that you actually don't need information about the device and stuff like that. You could do it based on how people interact. So they build a kind of like a social graph. So that is every time two devices interact and exchange information in Bluetooth, even though I don't know the IDs of those particular devices, I will log that interaction. And then I will build a graph and I will see who's talking to who, even though I don't know who the person is. Mm-hmm. And they collected that information for, I think, 2-3 weeks. And they showed that you could, based on that interaction information alone, using a graph neural network, so using graphs and AI, you could completely de-anonymize like 80% of the people. And yeah, with this, you start to wonder, like, if they can do this with Bluetooth when crypto's in place, you can do it with anything that is kind of anything that uses a graph, which is basically everything. Like social networks, Twitter, like you can do that for botnet detection. Some people are doing for botnet detection, because in the end you have the internet are machines talking to machines, a machine talking to machines, that's a graph. So the definition of network is that it's a graph. So any type of attack in network security, you can leverage this type of AI to improve in the detection. That's kind of what I've been focusing on my personal track of research in the KLopen. It's network security using graph neural networks to try to leverage that information in the topology of the network to detect botnets, to detect DDoS, things like that. So yeah, it's a little bit more complicated at the technical level of the math behind it, but I think it's super, super cool, and we're definitely going to hear more about it in a few years.
Yeah, no, it sounds very, very interesting. I hope we hear about it from you.
Yeah, well, let's see. I see someone has a question in the chat. Can you train an AI on your behavior? So just like you, yeah, that's pretty much what you should do. You can have an AI that learns how you interact with things, and then I guess you can export that behavior to your bots. But I guess you cannot do this at a scale again, because if you have a million bots that are acting the same way, then for whatever system you're attacking, they're going to see that is, even if it's you, even if it looks human enough, they're not going to have a million humans doing the same thing. So there's something fishy going on. So you can do it, but a small scale, indeed.
I guess you could also train a model about how a bot behaves to detect that bot.
Yeah. But the thing is that is harder, because like there are more or less infinite ways a bot can behave, right? Like, so if you want to learn the common pattern of all the bots, that's harder, I guess. But you can do that. But normally what you do is the opposite. You see what the common pattern of normal behavior is, and then anything that deviates from that, you flag it as malicious. So that's what we call anomaly detection. So anything that deviates from normal is anomalous, and then that's what you should detect it.
But sometimes, at some point in the past, I read a research based on that, which which initially seems like a great idea, where they say that they had too many false positives because the network wasn't behaving the same every day, every week, every month. So they were full, at the end, they were full of false positives, even if they weren't infected. So I was thinking that maybe if you, instead of trying, because at the end, I guess that if you want to map your whole network, that could be very big in a model, you need to map as regular a lot of different behaviors which the malware could use to behave like it, and so you don't detect it. But if you generate models that behaves like the malware, because at the end, in a lot of cases, at some point the malware is going to be found and you can run it, you can interact with it, so you can create a model that learns how this malware is behaving. Maybe if you have a lot of different models of how each family of malware is behaving, and you share it, maybe between governments, whatever, at some point you will know how each malware is behaving, and you will be able to detect it, even if you didn't create this huge model that knows how your own networks regularly behaves. I think that is something easier to share. It's like an EOC. It's like if you share a hash of the malware, but instead of that, you share a model of the malware.
Like if yes, I no, I agree. That's the normal classification. But the thing for that, the problem is that you need to know the malware first, and you need to have that label. So you need to have samples of the malware, and you need to know that it's a malware. And then I could argue that if you have that information already, it might be easier to get a footprint of the malware that you can share, that you can use in a normal like signature of the malware. So that's what we have in place now, right? Like this kind of like an antivirus. You know how a thing behaves, and then you share that. But the thing is, you cannot detect new malwares based on that. As long as it deviates a little bit from that footprint, you cannot detect it anymore. So where these other AI systems, what they try to do is have something more general. So instead of learning how exactly the malware behaves, you try to learn what makes the malware a malware. Because that's the stuff that you know for sure that most malware will share. That definition of maliciousness. So that's what you try to learn, which is a little bit hard.
Yeah,
Um,
because there are a lot of regular programs that aren't malicious, that
yeah,
behaves like a
and they
malware. They
did.
are going to be downloading updates, running them, executing things as administrator even. So I find that to be complicated. But of course, if you manage to do that, well, you have
Yeah, it
solved
is.
the
It is.
cybersecurity
It is
problem.
definitely complicated. That's what is not a solved problem. That's what like we're still trying to do it. Uh, I guess the good thing, the power that we have here is that AI can leverage like it has a lot of muscle, right? Like it can do stuff in a big scale and stuff that it might be very complicated. And for us, we might not see the pattern, but it might be that those benign applications they're doing this requests for updates in a specific pattern, whereas the malware is doing like in a completely different pattern. So that's the stuff that we as humans don't detect, but an AI can. And I mean, this is a completely unrelated example, but I just it reminded me like uh, some people like they broke like the crypto protocol for Wi-Fi because they saw that the actual requests for the probes to the router they were at specific timestamps. So you could break the MAC anonymization just based on that pattern of timestamp, and that's something that as a human you would never detect, but you just feed it to an AI and it detected it super fast because we wouldn't think of looking into that, but an AI does look into that. So
So
yeah.
an AI is going to be a better hacker than a human.
Eventually, I think so. Yeah,
Oh my
but
god.
also think about you're gonna have AIs defending from hackers that also yeah are better at detecting hackers than we are now. So it's kind of again an arms race. Nobody knows who's gonna be on top.
I will ask for an AI to redact my new CV to search for a new job. Cool, Abel. So thank you for this great explanation. Should we just finish this conversation with the adversarial image demo?
Okay.